I've used many cartridges. Today, we selected some typical ones to analyze and share our sites with you. How can we tell if the cartridge you are using is really good? I've taken out a few cartridges. Noted, these 4 cartridges do not represent any brand. This is purely an objective review. These cartridges come in pink, blue, and gray. They are all different, and their quality varies as well. Now, I'm going to show you how to judge the quality of a cartridge from these 3 aspects. Now, let's open the bottom of all the cartridges and check the needle inside. You can open them like I did, using scissors or a metal ruler. You can try to open them yourself, but please make sure to pay attention to safety. For example, with this cartridge, the silicone spring fell off before it was even opened. Let's lay out the opened needle in a row and test them one by one. Now let's test the first one. This needle is quite hard. This part has a welded joint, which is a good welding method. Such welding makes the needle stronger and the middle part is relatively thick. Let's put this needle on the table and press down on it with our finger. This needle is very hard, so we can conclude that its quality is good. Next, let's check its silicone spring. Hold the needle with your left hand and the bottom with your right hand. Then pull back until the tail of the needle is no longer visible. If the spring has enough elasticity, it won't come off. This means the spring's rebound is very good. A cartridge like this will move smoothly and powerfully with the machine during use. Its quality is good. Now, let's look at this needle. Its style is a bit different from the previous one. This needle doesn't have a welded joint, but it has a relatively thick reinforcement. The middle part of the needle is also reinforced, making this needle very good as well. This needle is very hard overall. Even when we press hard on it, it remains firm. Now, let's check the elasticity of its spring. It's excellent. It can fully meet the needs of professional use. This needle is a bit different from the previous one. Not only does it have a reinforced rod at the bottom, but the middle part also features a solid sticky design. Let's take a look at its spring. Its elasticity is good as well. This needle looks similar to the previous purple one. Let's check its hardness. It also appears very firm. Let's also check the elasticity of its spring. It's very good as well. Let's move on to the next one. Although this needle also has a similar sewing design, it doesn't have the same fixing structure as the previous ones. Because of this, it doesn't have good stiffness. Let's check its stiffness. It's very clear that this needle is soft. Let's check its spring. We will try again. The spring falls off again. I tested it several times, and it happened every time. This kind of needle is very poor. Let's simulate how it moves in and out on the machine. When you press it like this, the spring comes off very easily. Once the spring falls off, the working power during operation comes much weaker. This kind of needle is completely unacceptable. Next, let's take a look at this pink needle. At first glance, this needle is very thin, much thinner than all the others we looked at before. Let's check its actual stiffness. It's very soft. This is why I always emphasize that .18 needles are not suitable for blows. They are too thin and too soft. But this doesn't mean the needle is bad. It only means it's not suitable for doing blows. Let's also check its spring. It's very good as well. Now I will test the next needle. This white one looks a bit like the previous purple one. They both have the same welded design. But it's not as thick as the purple needle, and its tip is a bit long. A tip that's too long tends to be very soft. Let's test its stiffness. In fact, it is indeed very soft. Let's check the elasticity of its spring. It's also very easy to become loose and isn't very good. Now, let's look at this purple one. We can clearly see that this needle must be very soft because its tip is too long. Let's test its stiffness. It's very soft, right? Now, let's check the spring. No good. Before I even apply any pressure, the spring has already come off. Let's simulate how it would behave on the machine. This needle is not good. Let's move on to the next one. The internal design is basically perfect. Let's directly test the needle's stiffness. The stiffness is excellent. And the needle's rebound is very good too. Let's also check its spring. It's excellent. But do you think it's done just like this? No, we still need to do the final test. Let's take a look at the shell of each cartridge. The shell of these cartridges are all hollow, with a lot of empty space inside. But with the shell of this brown needle, tweezers can't fit inside. It gets stuck right in the white part. Looking from this angle, you can see it very clearly. This shell doesn't have this kind of design inside. So what's the purpose of this white part? Let's do a test together. We insert this gray needle, the one we tested earlier, which is very soft. After inserting it, we press it with our hand to simulate its movement. You will notice that it's very hollow inside, so the entire needle wobbles around. In other words, it's very unstable. Over time, the needle will wobble even more, especially if the spring's elasticity is poor. This is the stability test. Let's take a look at the other situations. As long as there isn't this fixed component inside, the needle will exhibit the same instability. Now, look at this needle with a stabilization design. With the same test, you will see that this needle is very stable. Even when we shake the needle, there's no wobbling. Even when we shake it with more force, it still remains stable. This is all because the cartridge has this white component inside, which provides stabilization. Even at high speeds, the needle stays steady. Have you learned how to judge needles now?